So in today's video, having read the Boundless white paper and that gone through the documentation, we will be going through what Boundless is all about, the Boundless vision, and how you as a user can come in. So the whole goal of Boundless is to make compute a tool that is tradable, that is financialized, and to remove the constraints that comes with compute. So that is the whole thing around Boundless. So users are not limited by computation or whatsoever, and it's a universal protocol where with this ZK tech you're not limited to one chain in particular. So we get to see what that is all about as we go through this video. Now, the traditional blockchain model is that there is global re-execution. So what that means is that, so supposing you are in a team, and that team you have to deal with issues like fine. So supposing you were in the stadium and there were 10,000 spectators, and then you have to verify 11 players from both teams, and imagine 10,000 persons on that stadium verifying those 22 players. It becomes something that is cumbersome. So in blockchains today, one node, for example, checks that something is done, and then you see countless number of nodes on the network trying to verify that stuff before we reach consensus. Like this, that is very, very bad. And the system, the network, the whole network is affected by the overall slow network. A slow node overruns this whole thing. And then there's limited execution capacity that can be done by a single developer. So that is another problem. And then there is so much buzz about ZK this, ZK that, ZK can do this, ZK can do that, but the overhead as getting talent that can develop ZK is one problem. And then to choose to develop ZK, they are fragmented. You can't see them in one place, so it becomes a very big problem. Then another challenge is the challenge of ecosystem limitations. Yeah, when you want to deploy, you choose a chain that you want to deploy to, or a rollup, and there you are constrained by the liquidity that is there. You are constrained by the users as a builder, and many other challenges that you have to pass through. So with Boundless, we don't have any of such in our hands. So what users does is that the network does is that it takes computation option and then verifies the proof that okay, you've done the computation. Let's see how it's so that is a brief about the Boundless stuff. So with that we can skip computation. Now Boundless is being used. So let me. Okay, we'll get to that in a minute. We'll get to that in a minute. Now, the Boundless is being built using RISC-0 architecture. So the ZK is built upon the open source standard, and the Rust developers who are welcome on board. You can start writing code from day one using the RISC ZK. Then it uses ZK stack, so there's no need for required trustless setup. And then multiple VMs will be supported in the near future. Then we can aggregate nodes into, I can combine proofs into a single aggregated proof. So that's one of the things about the ZK, RISC-0 ZK VM, built by RISC-0 team. So in the network, there is a boundless market. So the boundless market is basically the place where those who have those who need compute. Let's say person A, then there is person B that needs compute. So they meet together. So what actually happens as a user, you submit your request to the network. Like, okay, I want proofs with so and so parameters. then the prover, who is the one that is on the supply side, will come and then say, okay, you can provide this proof. So, but they were not going to do that just by, they have to lock up a stake. So that's why they will stake some tokens to that effect. So once they do that, they lock up the token, and then they are choosing, they will submit the proof, they will generate the proof, and then the next thing is that the whole network will verify the proof against these parameters that you initially brought. And then once it's settled, then the payment will be made, and then the stake of the proofer will be released back to them. And then you as a user, you can now utilize your proof in your application. So that's just the brief about it. Now with that comes the financialization of compute. And the financialization of compute, it means that we are with Boundless. If you read a Boundless white paper, one of the things you can see in the white paper is this. Time to put product. So how do we financialize compute? So compute is treated as a commodity that can be traded. You can with things like verifiable service agreements. You can enter different agreements with it. You can lock up the token, as you can use it as a collateral and all that. And one of the innovations as concerning this financialization of compute is the proof of verifiable work. That is, we're not just saying you did work. How can we check the time and the parameters, the power and every other thing that went into that work? That is how we're able to rate and know, okay, this work is worth this amount. So it's like a meter. You know, when you go to the gas station to buy gas, also, you know, some countries they say petrol for your car, PMS, premium motor spirit. You have to check, okay, I want to buy such and such amount. You put it and then it gets you. So there is two revenue streams for provers. One of them is for the work they do for the fees, and then there is token emission for them, just like in BTC. And then I talked about this. Now let's move on to the Boundless token. So the Boundless token, the ZKT is the primary token on the network. It's used for rewarding users. Users can stake it in order to be eligible for those as a prover. Those who are submitting the requesters, they are required to pay the fee in ZK, can stake it as I said. So that's a brief about the token. And then let's talk about some of the benefits before we talk about the use cases. So what does the Boundless Protocol provide? One of them is universal deployment, like I talked about initially when we're talking about the constraints of this stuff. We talked about ecosystem limitation where there's single chain deployment. Now with Boundless, you can deploy your infrastructure across all chains. Why? Because it's using the RIC0 standard. So any language that it supports, you can do that. Now the next thing is, and there's an abundance of compute. We are not limited by the number of them. No. The more there are nodes on the network, the better it is. So there's high performance, there's high security. Like I said, it uses ZK stacks. There's no need for setup. And there's global composability, verifiable proofs for cross-chain interoperability. So no more are you going to be dealing with bridges or high cost of bridging and all that. And then you can easily port Web2 apps and that over to Web3 in a seamless way. Now let's talk about some of the use cases. For scaling solutions, it can be used in ZK or optimistic rollups as ZK proofs. You can use it for coprocessors, for floating smart contracts and computations. You can use it in DeFi for trading strategies, enabling complex strategies, autonomous games, prediction markets, onboarding users, data privacy, and then ZK LM and ZK AI. How do we know that the AI models that we are using, they actually give us the right proofs and all that? So, that is a brief about the Boundless Protocol. Now, let's talk about some of the projects that are using the Boundless Protocol, their ecosystem. So, like we said, that this project is more than the white paper. So, we have Hibashi. Hibashi, they are currently live now. They give you a sales-like experience by using Boundless for their own other machine. The next is the Soon SVM, is a roll-up using its solar innovation machine. We have Criterion, and then we have MADA, and then this is the beginning and many other projects that will come about. So this thing is actually live. You can try it today as a developer, and you read the docs, and then you can start building. And that is a brief about the Boundless Protocol. Thank you.